Hi, my name is Pearl Uberu and I am a technical marketing engineer here at Databricks. In this video, I'm going to share with you how Unity Catalog centrally governs and audits data access across workspaces. As the data governance leader of your organization, you and your central governance team have been granted full admin capabilities and can grant access to workspaces or metastores to users, groups, or service principals in your organization. For the purpose of this demo, we will use the Databricks ML Workshop Notebook to see the power of access controls within Unity Catalog. And to get started, we'll need some data to work with. To do this, the data science lead has created a catalog called Nico_catalog. A catalog is the first layer of Unity Catalog's 3-level namespace. It's used to organize your data assets, and permissioning has been set for the data science team to use the catalog. Within the catalog, there's a schema titled Default that has already been created by the data science lead as well. A schema, also called a database, is the second layer of Unity Catalog's 3-level namespace. A schema organizes tables, views, volumes, and models. Permissioning can also be set at the catalog level, and in this case, it's been set for the data science team to have privileges to use the schema, create functions, materialize views, models, tables, and volumes within the schema. Within the schema, there's a volume called NP_volume, again created by the data science lead. A volume resides in the third layer of Unity Catalog's 3-level namespace. Volumes are organized under a schema in Unity Catalog. Volumes contain directories and files for data stored in any format and provide non-tabular access to data. NP_volume has a dataset called Lending Club that the data science team will use by granting read and write privileges on volume access. Back in the notebook, before we do anything, we're going to make sure that we can consistently reference the catalog and schema name by defining them appropriately. For the workshop, we'll be referencing the catalog as Nico catalog and another schema called user. Before any member of the data science team can even run this code, we have to make sure that we have our cluster set up. So let's create a new resource. With Unity Catalog, there are 2 different clusters that we support. One is the shared cluster, which is good for 90% of your use cases. Users can share it, and we support all of the fine-grained access control. Then we have the single user clusters. This is where if you want to do something slightly more advanced, maybe you want to use a GPU or distributed machine learning, then you can break out onto this cluster and safely isolate yourself. For the purpose of this workshop, we're going to use a shared cluster. Then we're going to load our Lending Club dataset from our volume and then save it as a Delta table called loan data for future use. After doing some exploratory data analysis on this loan dataset, the data science team would like to reasonably estimate a specific loan status given the data provided in the loan data table. To do this, a feature store table will be created called Loan Features Test 2. This table will house the features needed for when the model is trained and tested. As you can see, this table is referencing the catalog and the schema we created earlier, harnessing the power of Unity Catalog. Now we can create a training set using our features from the feature store and then test and train the model using MLflow. Then we'll register the model in Unity Catalog by referencing the same catalog, schema name, and the name of the model, which in this case is Loan Estimator. The configuration of the MLflow client to access models in Unity Catalog is referenced here. Now, let's take a look at where all of the tables and models reside in the Catalog Explorer. Under the Nico catalog and under the user schema that was referenced throughout the workshop, we have our loan data, which is our full loan data set. We also have Loan Features Test 2, which is the feature store table to hold our loan features. And then below that, as you can see, we have our loan estimator model registered right here in our catalog as well. If we click the model, we can set execute permissions to our data science team, giving them the ability to use the model when necessary. Similarly, our tables also provide permissioning, and we can showcase that by giving the data science team select privileges on the table. Speaking of tables, let's see how Unity Catalog provides row and column level security through row filters and column masks, respectively. The data science team knows that eventually the data analyst team might want to utilize the loan data table to generate reports. However, there might be some columns that may need to be masked due to the sensitive data that they hold. Or maybe rows would need to be filtered out so that the data analyst team can query a subset of the data that they need. To do this, it's very simple. First, we're going to see what our current data set looks like. This is what the data science team will be able to see since they have full privileges. They want to show the data analyst team only data where homeowners have a mortgage and where their income is hidden. So let's create the SQL functions. I'm going to leverage the power of Unity Catalog here by using the catalog and the schema where my data set resides. Then I'll create a function that masks the annual income and only allows the data science team to see it. Next, we'll set up a function that filters out the home ownership status to just homeowners with mortgages. Now, we can verify that our functions have been set up correctly and then apply these newly created functions to the loan data table. Let's take a look at our new loan data table. And here we can verify that our annual income column is masked to show the null value instead, and the homeowners are all mortgages. This table can now be utilized by the data analyst team as needed without any concerns surrounding sensitive data. And with that, you've learned how Unity Catalog centrally governs and audits data access across workspaces.